Hello everyone, my name is Fasika Imam. I'm a physics instructor at Lebawi International Academy. Today we are going to see something about capillary action, surface tension, adhesion and cohesion for 11th graders. So in this topic we will try to define those terms, and then finally we will try to integrate how this capillary action takes place in Kosovo 3. So to begin with, let us define what capillary action means. So capillary action is commonly called capillarity. It is an important phenomenon in nature and life. So capillary action is fluid's ability to move through the narrow tube-like space known as capillaries within porous or spongy materials. And this capillary action is just the tendency of a fluid to be raised or suppressed in a narrow tube or capillary tube, which is due to the relative strength of cohesive and adhesive forces. Let's see the difference between cohesive and adhesive force. So when we say cohesion, it is a property of the same molecules to stick each other due to substance mutual attraction. And the force between like molecules is called cohesive force. We can take force between water molecules as an example. But adhesion is the property of different molecules or surface to cling to each other. Forces between unlike molecules are called cohesive forces. Between water and glass molecules there is an adhesive force, or we can take forces between water and glass molecules as an example of adhesive force. And there are basically two types of capillary action that are called capillary rise and capillary fall. Let us see the first one. So when we say capillary rise, it is a tendency of liquids to rise in tubes of small diameter in opposition to external forces like gravity. But when we see capillary fall, it is liquids like mercury, which have high cohesive force, show capillary fall. But in capillary fall, for instance, if we take liquid like mercury, this mercury liquid have high cohesive force, and it shows capillary fall inside such glass tubes. The other point is meniscus. So the curving of the liquid surface in a thin tube is due to the competition between adhesive and cohesive forces. The meniscus of water is concave in a glass tube because its adhesion to the glass is stronger than its cohesion for itself. But if you see the meniscus of mercury, it is convex in a glass tube because its cohesion for itself is stronger than its adhesion to the glass. Let us see the occurrence of capillary rise and fall. So capillary rise occurs when adhesive forces like between water and glass is greater than the cohesive force between water molecules. Water rises in capillary tube until the weight of the water column supported equals the upward force. In this case, the contact angle is less than 90 degrees and the meniscus is concave. But capillary fall occurs when cohesive force, like between mercury molecules, greater than the adhesive force, like between mercury and glass molecules. Liquid in capillary tube is depressed to a distance h below the surface of surrounding liquid. So in this case, the contact angle is greater than 90 degrees and the meniscus is convex. Let us see the other point, which is surface tension. So cohesive forces between molecules cause the surface of a liquid to contract to the smallest possible surface area, and this general effect is called surface tension. Liquid surface behaves like a rubber membrane under tension. We can see spherical shape of water drop and water striders as an example. Let's see the following diagram to explain the concept of surface tension. If you see, for instance, these two molecules, molecule A and molecule B, in the case of molecule A, there is no liquid molecules above. Therefore, net force exists and which pulls it down towards the interior of the liquid. But when we see molecule at B or molecule B, it is surrounded on all sides by other similar molecules. and the net attractive force is 0 since it's attracted equally in all directions. And studies show that surface tension is proportional to the strength of the cohesive force, which varies with the type of liquid. And it is defined to be the force per unit length exerted by a stretched liquid membrane. And the SI unit of surface tension is Newton per meter. Basically, there are three factors that can affect the surface tension of a liquid or a fluid: the intermolecular attractive force, the temperature, and surface active agents like soap and detergents affect the surface tension. If you see the first one, as the intermolecular attractive force increases, the surface tension will increase. And when the temperature of the liquid increases, then since its intermolecular attractive force will decrease, there is a decrease in surface tension. The third one is surface active agents. So when we use soap and detergents in a liquid, then its surface tension will decrease. Now, how can we calculate the capillary rise of a fluid in a glass tube or in a capillary tube? So the formula for capillary rise can be derived by balancing forces on the liquid column, and the weight of the liquid is balanced by the upward force due to its surface tension. So to calculate the capillary rise, we can use this formula. And as you can see from the diagram, there are factors that can affect this capillary rise. The first one is the density of the fluid. So as the density of the fluid increases, its capillary rise will be smaller. Second one is force due to surface tension. So as the surface tension increases, its capillary rise will also increase. The other one is radius of the capillary tube. So as the radius of the capillary tube increases and gets wider, in that case the capillary rise will be smaller. And acceleration due to gravity also affects this capillary rise. If you do this experiment, for instance, at the surface of the moon, you are decreasing acceleration due to gravity, and hence the capillary rise will increase because they are inversely proportional to each other. And the last point is angle of contact. In this equation, the value of theta affects the capillary rise. So from 0 to 90 degrees, since cosine value is positive, we will have capillary rise. But between 90 degrees and 180 degrees, since the cosine value is negative, we will have a capillary fall. So far, we have seen something about capillary action, surface tension, adhesion and cohesion. Now let's try to apply this concept in real life. So, as you all know, Kosovo tree, in its scientific name called Hagenia abyssinica, is one of the most ecologically important tree species, which is sparsely distributed in the highlands of Ethiopia. The species has a high nutrient quality of foliage and flower buds for managing soil fertility. The shade leaves are easily decomposable, and it is advisable to apply the green leaves in order to improve soil quality. Let us see the water movement in Kosovo tree. So the first one is negative water potential draws water into the root of the tree, and this cohesion and adhesion draw water up the xylem of the tree, and then transpiration draws water from the leaf. So generally, water movement through a tree is controlled by the tug of war between the water availability and movement in the soil versus the water loss from the leaves. Have you ever wondered how water gets from the roots of a tree to its leaves? This is done with the property of water known as capillary action. So capillary action is water's ability to move through the narrow tube-like space known as capillaries within a porous or spongy materials. Plants absorb water from the soil through their roots. When water enters the soil and reaches the tree roots, water molecules are attracted to the molecules in the root, and this process is known as adhesion. And it happens when water molecules are attracted to molecules in other substances, and this attraction causes the water molecules to move closer to the root molecules and be drawn through the narrow capillary tubes inside the plant. For capillary action to occur, the attraction between the water molecules and the tree molecules must be stronger than the mutual attraction between all water molecules. Now let us see other applications of capillary action. So as we all know, water will be absorbed by roots of a tree, and because of capillary action it will move from the roots of tree towards its leaves, and we use tissue papers to clean a table like you see in the diagram. Just in this case there is a flow of fluid because of capillary action, and blood samples is taken as a result or because of this capillary action. The other applications of capillary action is paper towel. If you see, for instance, we can displace fluids from left and right hand side fluid towards the middle one using paper towel, and this paper towel transfers the fluid because of capillary action. The other one is we see light from ordinary kerosene lamp because of capillary action again, and we can take this capillary action to draw ink to the tips of fountain pen nibs. Before we finish our today's lesson, let's recap what we have seen so far. So today we have seen something about capillary action, and capillary action describes the ability of a liquid to flow against gravity in a narrow space such as a tin tube. And there are two different types of forces related to capillary action that are called adhesion and cohesion. When you say cohesion, it is molecular force between like molecules. It's an attractive force between like molecules. But adhesion is an attractive force between unlike molecules. And again, we have seen something about surface tension. So surface tension is a property of the surface of a liquid that allows to resist an external force. And finally, we try to integrate and see some applications of capillary action. And we have seen that root hairs of Kosovo tree enable capillary rise in the tree. And capillary action works in blood sampling, ordinary kerosene lamp, and drawing ink using pen nibs. I hope you enjoyed the lesson, and that's all for today. Thank you.